Hello ladies and gentlemen, and welcome to another video. Please take the time right now to copy down this problem so that you can follow along. When you start off any 2D kinematics problem, always start off with a little drawing with all of the given information. So here we have an object being fired at 15 meters per second at 30 degrees. The VOX and the VOY is one of the first pieces of information that I want to find. Now the VOX is the adjacent one to the angle, so I'm going to use my cosine trig identity. Fill in all the necessary information, adjacent being VOX and hypotenuse being 15, multiply both sides by 15 to isolate the VOX, so I can find that VOX is 12.99 meters per second. I'm going to do the same steps for VOY using my sine trig identity. Plug in all the necessary information, multiply both sides by 15 to isolate VOY to get 7.5 meters per second. Alright, now to solve for A. Maximum height is asking for a variable that's in the y-axis. So all the variables I write down will be for the y-axis. Going to write down all the given and the recently found pieces of information. A sub y, of course, being negative 9.8 meters per second squared for gravity. I'm going to choose a kinematics equation in order to solve for my time. To get 0.765 seconds. B, max height. Now when it's asking for max height, once again it's asking for something in the y variable. So I'm going to write my list of variables and I'm going to write down all of the known values. I'm going to start off with a kinematics equation. But this time I'm going to replace all the x's with y's so that there's less confusion. Now, please take note of the t squared. Most students forget to square the time. Multiply all the necessary information to get my final answer. Max range is x. Describes how far. So how far is the projectile going? I'm going to start off with a sketch, and then I'm going to write down all the information I just found. I'm going to create my list of variables. Always start off with your list of variables. And I'm going to write down the information that are known and that are determined. The 12.99 was found from the beginning of the video. Now, VOX and VF of x are the same unless there's a sub x, which in physics is usually the air resistance. Most of the time, air resistance is not applicable, meaning your a sub x is usually 0. And it is assumed to be 0 unless stated otherwise. The time, 1.53 seconds, was found by multiplying the time it takes to get to the max height, which is the halfway point, by 2. Here's a little equation to describe the process. 2 times the max height in the y direction. I'm going to start off with a kinematics equation. And then I'm going to fill in all of the necessary values. To get my final answer of 19.87 meters. Final horizontal velocity. Now, VF of x is always the initial velocity if a sub x is 0 meters per second squared, meaning that it doesn't speed up or slow down unless there's air resistance, or stated otherwise. Here's a little proof to show that my VOX and my VF of x are both 12.99. VF of y is the same as v initial y because of this thing called symmetry. Now this is true and only true if the projectile starts and lands at the same elevation or the same heights. The only big difference is that when you start, it is going up, but when it comes down, it's going to be a negative value. And here's my proof. Final direction and velocity. In order to determine the two, what you have to use are the values that you just recently found, your v final y and your v final x. Now the wonderful thing about this is that it creates a beautiful right triangle, and with right triangles you should always create or use the Pythagorean theorem. To find the direction, you have the opposite side and the adjacent side. Plug in the values that you just recently found and find the arctangent or the inverse tangent of those two values to get the answer of -30 degrees. To find the hypotenuse, I use the Pythagorean theorem. Square root both sides to get my hypotenuse as 14.9967, rounded up, 15 meters per second. Okay. Due to symmetry, this should be the same velocity as you had in the beginning. Alright, are you ready for this joke? I am currently reading a book about anti-gravity. It is impossible to put down.